After reading example 6 on page 247, what you might have noticed is that they sort of skip over solving this equation. So let's just take a little minute to see why this is a difficult equation to solve. So if I tried to get x by itself, I might do something like divide both sides of this equation by 200. Right? That seems like a reasonable thing to do. So then two of these zeros are going to be gone. So it's really like taking 1,000 divided by 2. So 500 equals this numerator 1 plus x over 12 to the 240 power minus 1 over x over 12. All right. I'm still trying to get x by itself, and I've got two x's, but I might first just try to get rid of this denominator by multiplying both sides of the equation by x over 12. Right, that's going to get rid of this term here. So I'll be left with 1 plus x over 12 to the 240 power minus 1. And then over here I'd have whatever 500x divided by 12 is. So I've got x here and I've got x here. Now if in general when we have x's on both sides of the equation, we just bring them together. But notice that this 1 plus x to the 12 is being raised to the 240 power. And just a side note, 1 plus x to the 12th to the 240 power, that is not equal to just 1 to the 240 plus x over the 12 to the 240. That would be a bad misuse of order of operations, because remember, this is really saying I'm multiplying 1 plus x over 12 times 1 plus x over 12 240 times, right? And so that would be like a huge distribution problem. Like just these two alone would require us to use that sort of acronym FOIL for distributing. But now we have to do it 240 times. Like just that's a monster. There's no way we're going to actually expand that out. So if we can't expand that out, we're not going to have any hope of combining the x terms. So we do need to use technology to solve something like this. So you're not going to have to be able to do that. You're going to just be doing part A of checkpoint 5.